Okay, so while you guys are warming up and getting Rhino opened, I just want to talk about today. So we're moving into the phase where I'm going to be introducing basic materials and rendering. And but before we get to any of that, I want to talk about cameras. And cameras are one of those things that I find doesn't get taught well enough in school, like a lot of other modeling topics. Rachel, can you grab the door for me? Thanks. A lot of times you'll see, like, actually take this view for instance. Is there anything you guys find particularly like wrong about this view, or not very useful, or like is this fine? You guys like this camera? Like the way that I'm looking at this building right now?
Not as much as like the opposite side where it shows more of the structure. Like there's a blank facade on the left.
Well, there's that, but let's just talk about. Let's say that I really did want to show this. Like, what about the position of the camera? You know, like, I mean, that sort of thing. Like, is this the best kind of reading of it? Is this an accurate reading of it? Like, is this the view that I want to show? Yeah. Okay. So that's something, right? Like, that's something that a lot of people make mistakes with. Is that it's actually floating. Like, where's my eye level? Like, if I was going to draw like the horizon line, right? Where does that fall in this? Like on the building, where does that fall? Let's say. It's not eye level. I think that's right? It's not 6 foot off the ground. What does it look like? Yeah, 13, 14 feet. It's in like the middle of the second story, right? So either I'm up on a ladder or in like a crane or something, right? And you could say like, well, there's not anything like wrong with it. I mean, you do get to see the whole facade. It's kind of balanced. Like in terms of like the fact that the horizon line is roughly in the center of the screen, like but it isn't really your experience of it if you're walking up to it on the street or if you're viewing it from across the street, which is probably, that's like, you have to think of the camera as an analytical tool and not just as like getting your thing out of the computer. As an analytical tool, right? There are lots of variables that we can actually like control. We can control where the camera is, how high the camera is, the amount of perspective distortion in the camera, in order to construct a view of the building. And the people who do this that we pay attention to are architectural, like people who take architectural, like who take photos for like magazines or for books. There's a bit of like photography in what we're doing. Okay, look at an architectural photo. You would never see this. Like, you're not going to get a guy up on a crane who's going to take a picture of a building. You're going to see someone who's going to give you the experience of that building, from the street. Now, what's wrong with this view? Like from that, if you're thinking of this as an architectural photo, what is this doing that we don't like quite care for? It's distorted. And that happens. Like lenses will actually do that, but what photographers will do is they will actually correct for it. Usually with a reverse fisheye, they have a lens that will actually push the edges out. Okay, why don't we like distortions? That's kind of a rhetorical question, but just kind of humor me. Okay, yeah, it's not like accurate, it's pinched, right? Like the building doesn't really slope like this, okay? What happens in photography, like the reason, like what you want is for the vertical lines to be vertical. What that communicates is it's less, I mean, you can have distortion, in this kind of axis, like this kind of pinching, but keeping the verticals vertical gives you stability. You don't want a building that looks like it's going to collapse in on itself or if it's going to fall like on top of you, okay? And this is one of these things, again, guys, and I'll talk about this more in computational methods, but like where the computer really taught me a lot about like sort of, where it taught me a lot about like physical phenomena. I never really like thought about photography, really thought about the view of the building like until I really started to play with the variables in the computer because you have complete control over it. Like it's your laboratory, right? And maybe really think about like why photographers like take the pictures of buildings that they do and like in the way that they do. So, you know, again, I would think like the view that I just had, like I've seen students do that. I've seen students like do this. The other one is this kind of helicopter view, right? Which is like, again, you're in like a helicopter. And it's this thing where you don't really get a good sense of the scale of it. You don't get a good, you don't get the kind of human perspective of it. The only way you'd see this is if you're in a helicopter or if you were in a tall building across the street or something. Like it doesn't communicate that experience to you. So, you know, and I mean, there are uses for these kinds of drawings, these kinds of renderings, but what I want to give you guys a sense of is, well, how to make any image you want of a building, so that if you have a specific thing you want to show, how do you get that picture in like an analytical way, okay? And that's what we're going to be talking about today. So before you even begin rendering, you have to think of the camera as a tool, okay? Then we can get into like materials and lighting and all that sexy stuff. And I would say even as you're designing a building, like having certain views in mind, like you know a view across the street, a view into the lobby, you know, having these things in mind as you design the model, as you're designing your building, will keep you in check, right? You're like, I think that the columbarium is going to be experienced like this way, or I think the chapel is going to be like this, right? So you put a camera there and it's set up, and as you design it, you keep checking back with yourself, right? And it's a camera that's like from a person sitting in a pew, or it's a camera that's a person that's walking through like your promenade, right? You have kind of a cinematic experience of the building, and it starts by generating these cameras, okay? This is a really, like, we push this really hard as a design tool. Like, you know, use perspectives as a design tool when you're like drawing a building. It's the same deal here. These are perspectives, okay? Okay, so that's what we're going to be talking about today. And again, this is the model that you guys have already kind of looked at, so I think it's a good thing to get started with. What we're going to do is we're going to experiment with putting cameras in different places in the building. I'm going to show you how to navigate using that. And so I'm recording this because, you know, again, like, I don't think you're going to use it like right away. You might use it as you begin modeling your building. I think it's always good to set up cameras early. But if not, just keep this in reserve and you can come back to it, and then you can use these cameras yourself, okay? This won't take the whole class. Sam just came in. We're gonna, if you guys have questions about your projects, about your models, we can talk about that like today. So we'll have a little bit of time to help you out with that. This evening I'll have everything posted for the requirements for the final, okay? So when you're working with cameras, it's helpful to have the like what we call like the quad view. And this is in Rhino, right? This is a 3D modeler, but we're working on a 2D screen, and a lot of our design elements are in 2D. So having like multiple views of it from the front view, the top view, the side view, and perspective all simultaneously is really a helpful way to work with these models. And if you don't have that quad view, a quick way to do that is just to click this button up here, you know, like the 4 viewports, and that'll actually give you the default layout, which is top perspective, front right, okay? And that's kind of a quick way. And you see this one's actually a shaded view, and these are all wireframes. And you can mess with that. We've talked about that before. If you click the zoom extents, you know, we would get, if you right click it, you get the same zoom on all of them. So this is the model we have. It has this kind of context, and it has this you know, like building in it. And the trick is, so whenever you're like moving your view around, right? Like I'm just kind of rotating, zooming, panning, like all the stuff we've talked about. That's essentially a camera, okay? And you can save a camera. You can save any view that you want, and you can recall it later by going into View, and then saying Set View, and then you go to Named Views. And this is like, and it says Saved View Names. You can say Save, and you can say like, you know, I'm just gonna call this perspective 1, because it's a perspective view. And then you say okay. So now it's in there. Okay, it's in my named views thing. Now if I go in and I'm in a different view, or I change this view, I go crazy, find another view. I can always go into my list now if I right click this, and I can go to set view, and perspective 1 will show up. And if I click, that's gonna load that view. That's a saved view. Okay, so that's essentially like a camera. It has a location in space. It has a certain focal distance. You can make it, so the point is you can make a camera by basically taking any view that you have and then saving it. And that's kind of the foundation of this, right? Is like saving a view and like getting it back later. Doesn't matter, even if this viewport says perspective 1 and I'm like rotating and I'm doing all kinds of wacky stuff with it, if I go back and I say perspective 1, it's going to snap back to that. So even though that says perspective 1, that view's been saved. Now, I can update that. Let's say I swing around to the other side of the building and I got like this view, okay? I can go into view, set view, name views, click on my one that I already named, and I can just say save, and that'll actually override it, okay? But until you do that, that's it, okay? And you can go in that same menu and you can, you know, like actually take out views. You can import cameras from another file. There's lots of stuff you can do there, but that's the gist of that. Okay. Okay. So save views, right? That's the foundation. Whenever you do something, you get something you like, save it, and that'll stay with your file. Okay. It's really useful to have saved views because, you know, think of it this way. We could do renderings of the building, right? Like we can do like Maxwell renderings. Then we can do make 2D lines using the same camera, and we can overlay them in Photoshop or something. So if you save the camera, you could produce multiple different renderings of the of your building, and then they'll just snap into each other because they're the exact same view. Okay, so it's really useful to have that view be the same. It's next to impossible to find the same view, right? Like in a million years, I probably couldn't get that exact position, that exact like degree. So just save it. Okay. Okay, so that is actually, I mean, that's the theory, but it's really crummy, right? Because I really don't have a lot of control like over exactly where that is. Like, is it 5 foot above the ground? Is it 7 foot? Is it 24 foot? I can eyeball it. The perspective's a little distorted. Like, it's not, I don't have optimal control over it. So the way that I get that is, so this is my viewport that I've been working in. Okay, let's go back to quad view actually. So I'm in perspective view. I'm shaded. You have to turn on the camera, and there's different ways you can do that. If you go into view, you can go into set camera, and you can say show camera or F6, right? And so you can see that the camera, so I mean it was in perspective view. That means that this is the camera in our space. This is the camera that is giving me that perspective view. Whatever viewport I was in when I say show camera, that's the camera that shows up in all the different viewports. I can't see the camera here because I am the camera, right? Here, so this is the camera like apparatus. Let's take a look at the camera actually. I'm gonna give you a handout that has these, but I just want to establish a few like I want to give a name to some of these things so that we're speaking the same language. So this is the camera point, and it's kind of like the focus. It's like where your eye is, okay? And so if that is 6 feet above the ground, right, that's my little cyborg, eye, that's at 6 foot. If it's 30 feet above the ground, that's where the view is taken from. This point right here is the target point, and that's the thing that I'm looking at, okay? Target, so there's camera point and target point. The line that's made between the camera and the target, right, is points at what you're looking at. Okay? Let's take a look at that in practice here. So if I have this view, this top view, this is my camera point. Oh, another thing too, guys, that's really useful is to lock everything that's not your camera, because you don't want to accidentally, pick things that aren't your camera. All right, so lock your layers. If I pick the camera point, and I pull it in the top view, you can see that actually adjusts and it's actually snapping like crazy. I'm going to disable snaps here. You can see that the target point stays the same, but I'm orbiting around it. So now, that's where that point is. And you can see that I can move that point in multiple views. So that point's really high off the ground right now. I can move it lower on the ground in the front view. And I can move it, in the X and the Y and the top view. So you use the different views to get the point exactly like where you want it, and that sets up your view. And the same goes for the target point. So the target point, again, I can move it up and down. See, it's like I'm nodding my head or moving my head side to side. So again, you take that target point and move it to get the exact like view you want. And notice the lines that radiate out from this, like that's my focal distance. So this is what the camera sees. Whatever's in that cone is what the camera sees. That's a representation of that field of view. Okay? Go, question?
Yeah, if you have your saved view, if you go and you revert back to that, will that change your camera?
Yeah. If I was in this viewport and I load that view,
Yeah.
then that'll update the virtual camera exactly. Okay, so there's that, and then there's this other point that's in the middle, and I call this one like I call this one like the control point. I don't think it actually has a name in the Rhino instructions, but as the control point, if you take this point, it's like a fulcrum between the camera point and the target point. It lets you move the whole apparatus without actually like disturbing any of those other parameters. So it's like if I have an angle that I like, but I want to keep it like on like a dolly, right? If I'm like a film producer, I have like my camera on like some train tracks, right? I can dolly side to side. It's going to preserve the same angle and the same general direction. Okay, doesn't go up or down unless I use it in this view. So here I can actually make the whole thing go up and down without changing the angle. So that's the control point. Okay. Okay, and then there's this point, and there's this point that makes me very angry, and I call it the devil point because it absolutely ruins my camera all the time. It's actually considered like a rotation point. I don't know why you would ever want to like turn your view like 45 degrees. It's like a funhouse thing, okay? But this point, this devil point, is, okay, so the target point is here. Target point's useful, right? Move this thing around. Right next to it in 3D space is this rotation point, and if I start yanking that thing, and you're like, oh, that's not a problem, Nick. We could just like undo it. You actually can't, because the undos for the camera are stored differently than the ones that are for anything else in the file. And when you start undoing the camera, it first of all, you might not, every time you move it at like a half a degree, it counts as like an action. So what I just did is like 300 undos, and if I keep undoing it, it will crash the program. And so basically, it's like if you touch that point, if you look at it funny, it'll screw your camera, and you have to start over. So just don't touch it, don't acknowledge its existence. And why is it so dangerous? Again, because it's in 3D, like from a top view, you could confuse it with the target point. So be really careful when you choose it, that you're not so choose it in a side view or something where you can tell which is which. Okay? Let me I'll try to like, so there's view, so there's actually like there's undo, which doesn't undo, and then there's undo view change. And see, like, you get like, that's all you get. It's rotten. You'll almost never make it back. Look at that. It just okay, so I proved my point. I'm totally screwed. See, like it's not a good camera now. So what can you do? You could reload your save view, and actually that's a great point that that Sam made. So that's the saved view. This is what the view looks like in terms of the camera apparatus. Look at how close those are together. If I choose, it's like, oh, camera point. You know, it doesn't say which one's the target and which one's the rotation point. It just says camera point. So guys, what you want to do is choose it, because, okay, this is the rotation point, because it's on top. It's going to pull you, okay? This is the target point. So choose it here, and then you can move it here, okay? I'm trying to be jokey about it because I want you to remember it. Like, it's not that big of a deal, but it's annoying, okay? It's the devil point. Okay, the last point in this thing is like a focal distance point. So there's a point that's on the corner of this box. And remember, these lines are kind of the vanishing lines of this of the view. If you pull, whoops, go top view. If you push and pull that point that's on the corner, it changes the focal distance. And why does that matter? Is because if you have a very, like, it changes the distortion of it. And if you zoom in though, like the thing is, this is what that crazy fisheye lens like does, is that it actually distorts it, and you can get it to go distorting out or distorting in. And then if you just zoom in, if you like dolly into it, I go to set camera, adjust lens length, and dolly. I mean, you can get so it gets pinched, you know, like distorted or flat. And if I flatten it, like I can get a view that's very, very flat. I can zoom in to it, and that actually gives me those vertical lines that I want. Okay, so if you adjust that focal length, even if it seems like crazy because it makes that foreground really like distant, you zoom into it, you've got a nice flat like view of your building. Okay. I mean not flat. I mean the lines are vertical. You don't want to make your buildings like too flat. Like you want to make sure like that you can read this facade. So you want to give yourself enough of an angle so that you can read, you know, this composition and that One thing my students do is that they'll want me to look at like this, and that's what they give me. And everything is like so tight in perspective that it's hard to read that facade. So you really have to adjust the camera point and the target point so that you get that read that you want, right? And this is the art, you know. This is where it comes in, and you know you can pan and you can zoom and dolly using the viewport controls, but this gives you precision. Like it shows you exactly, like I want to view kitty corner to that building. Like this is where I'm standing, and target point. You're like, I am looking at, you know, that window or something, right? So you can say exactly where you are and what you're looking at and make that camera obey you, you know. That's really powerful. Now, the last piece, the next to last piece I'm going to show you is if you open up the properties panel and you go into that camera, so I go into perspective, right? The camera for perspective 1, right? If I go into the properties view, so that's F3, look at this. It has the lens length. It has the X location of the camera, the Y location, the X target, the Y target, the Z target. So I can say I want to look at a spot that is exactly 40 units above the ground, and my camera Z is exactly 600 foot, 6 foot above the ground. You can type it in exactly. You can get like laser precise to exactly. So if you ever wonder like how high off your camera is, don't eyeball it, type it in. Okay. Now, if your topography is changing, you want to have it so that it's 6 foot above whatever the topography is. Okay, so be aware of that. It's not just 6. If you're at 100 foot above sea level, it's 106. All right. So you should always know where your camera is. You should always be able to put it exactly where you want to, because you have these controls. Okay.
Can this interface with the parallel projection operation you had earlier?
Parallel projection.
When we were doing the axiometrics.
It can, but that actually is a distortion. Like you're actually distorting the geometry.
Okay.
But you can position the camera absolutely using this method.
Okay.
Just that the geometry is different. Yeah. Another thing, guys, is this lens length. You know, again, you can manually type in the lens length. So the smaller the length, the more, you know, this is going to distort this, you know, more. So if I go down to like 10. And then if I go in, and there's some other camera controls, which I'll talk about in a second, but if you go into the set camera, I can do this like adjust lens length, and this actually acts like a zoom. So, you know, that's actually going to adjust. It's the same difference. Okay, so I can actually adjust that length. So the greater the lens length, the like flatter, you know, the image, the less the more pinched it is. And then there's this other command called lens length and dolly, which I kind of call the Hitchcock camera because it looks like the movie Vertigo. Like it lets you play with, so you can see how that actually creates. You can add depth to it. What that does is it moves the camera and the lens length simultaneously, and so it actually creates this kind of you can add more or less distortion by just kind of eyeballing it. So flat, deep, flat and deep. Okay. So I'll show you some uses of that in a second. But anyway, so these are the manual controls for the camera. Why don't we just right now? Why don't you practice getting a good view of one of the facades, or make a specific view of the building, right? So take a camera in perspective, turn on the camera, put yourself across the street from the building at like an eye height, and look up at the building so you get a view of it. Okay, and then maybe play with the lens length. See if you can flatten it out so it's not so distorted. See if you can get the lines to be vertical. Okay. So just a note on the vertical thing. So what you want to do is probably, so this is kind of distorted right now. So they're kind of pinching upwards. If I pull back the lens length to be pretty small, okay, so I can adjust the lens length, and then I actually move my camera. Well, actually, it's not what I want to do. Hang on a second here. Making an undo to the camera is really hard. Oh, you know what? Okay, actually, this is so. What you do is set the camera up for a particular lens length, and then what you can do is that you can always actually crop it out later. So like you would actually render it really large or do the make 2D, and then you actually just crop out all of the distorted parts. Let me kind of show you really quickly here. Let me adjust the lens length. Oops. Hang on a second. Apologize here. It's way distorted. Okay. So if I had a view that was like that, where I got the lines to be relatively vertical, I'm gonna go ahead and hide the site. And then if I did Make 2D, and I select, all the objects, and make that view. So again, even if it's very small in the viewport, I can still do like a Make 2D of it. I didn't get the distortion out as much as I wanted to, but if you can pull back far enough to reduce the distortion, just make that drawing of it, and then just crop out the distorted parts of it. That's kind of a trick. Okay. I'll see if I can come up with a better example of that, but. Just undo that. If you guys need help, raise a hand up, and Sam or I will come out and help you guys with it. But try to get a good architectural view, and then save it. Okay. We might talk about what a good view is as well. But you want it to be, not too flat and not too distorted. questions about their cameras? Takes a little bit to get kind of used to it, to kind of get intuitive with it, but you really do want to get a very specific view. You know, don't just kind of like fly around and say that. I mean, this is really about like positioning things exactly where you want them. So like, you know, getting the view of the facade of the building would be really important to you, but to kind of get that sort of like that money shot of your building, right? Do we have any questions about their cameras?
It's just a matter of playing with it.
You know, once you get used to the settings. Another thing you guys want to try on your own, like I'll post this up as kind of an assignment you guys can work on your own. But another thing I want you to do is work on interiors. This is something that like we have a lot of trouble with describing in architecture. I feel like we don't do a lot of interior work. But if you have a model of your building, right, you can begin to think about what the space looks like on the inside. And a big piece of that is actually getting the camera view right, so that you can actually, you know, see the inside of your building. You know, how about that? So I'm going to go ahead and turn on a camera, and I'll show you. I'll look at some interior stuff. So the interior piece of it is very similar. Only you take the target and you move it, you know, inside your building, and then you take. I mean, you take your camera, and then you move the target inside the space, and you need to adjust it so that. And this is where the focal distance really becomes. I screwed my camera view up there. Where the focal distance really becomes important. You could start. The problem is you can't just zoom into the space and set your camera up. You really have to actually take that camera and move it to a space that's inside your building. Let's start setting this up here. So now I'm inside my space and zoom in. And you can see though that the problem is that the depth of it isn't enough. Let me go ahead and lock my space here. So if you have to go in, you have to make the lens length a lot smaller. Okay, so you can start to see. Just like a telephoto lens, right? Then you can take your camera point and position it, you know, so maybe I'm inside the courtyard space. And I move that target. And so you can actually create a view. I'm looking at the first floor, if I'm looking up at the second floor. Kind of like a video game. But you could say, like, you know, I want to put myself on this, like, on the top of this stair. So I'm going to move myself in the two viewports. So now I'm on this stair. Maybe I need to move myself around a little bit. Move between these two. And then maneuver my camera so that I can actually see my space. So, you know, again, I'm working in plan, I'm working in the side view so that my perspective is actually what I want it to be. And then you can begin to adjust. So once I've got that lens length kind of established, I might go in and play with the lens length and Dolly again. So again, I can kind of compress that space or elongate it. You don't want to make it too distorted, but you do kind of want to set up the view. And then you could do a series of cameras to establish kind of like a promenade. So like as I move, you know, kind of up the stairs and around. So you have another camera, not too high up though. That's kind of like a security camera. But you know, looking down over this ledge here, so you can get the exact view you want from inside of your building. You can set that up, and you know, again, playing with the lens length to kind of see what you want to see, but remove the distortion. So you know, that view, you know, like it doesn't look like I have very much in my view, but if I go in and I make 2D that view, like if I say make 2D, and I select. I'm going to delete these other make 2D layers first of all. Sorry. Is it going to let me? Why isn't it going? Maybe there's nothing on them. Okay. You know, if I go into that view and I select all, I'm going to hide the site. Let's draw it. Let me take a second here. You're actually going to see everything, even though it's outside the viewport. You're actually going to see the whole piece. Just takes a second. But that's kind of a trick, okay? Yeah, let's see if we got it. I could be wrong, but now you're like, oh, that's crazy. It's like nothing. But if you zoom in, if you like zoom way in, it is actually all there, and you can kind of crop it out. That's kind of a bad example, but the idea is all those lines are actually like in the file. Remember, Make2D is a hack. Like, it's actually not meant to draw like the lines for the thing. Anyway, so you could do that to get a line drawing of your space, but the gist of it is that you have your camera in the space, and you adjust the settings of it so that you can see as much of it as possible. Okay, I'm going to show you one last piece, another way to use a camera. So this actually starts from, if you have a viewport. Let's look at the other side of the building. Look at the back side. Yeah, if we're looking at the facade of the building, right? You can do these kinds of studies, and these work really great for sections, but you can also use them for like facade studies. When you have a camera, this is my back camera, I can change the projection of it from parallel to perspective. Okay, and let me just zoom in. Whoa. Oh, you know, I have all these crazy lines I drew. I'm actually going to reset the file here. Those Make2D lines are going to mess me up. Okay, let's go to back view again. And I'm going to hide the site. And I'm going to zoom in here. So if I go and I change my projection to perspective, I've actually got that view of the building. And if I go in and I do... So I've changed that camera from a parallel projection, which is the orthographic projection, to an actual perspective camera. I'm going to move my... Oh, shoot. I was in the wrong view. Let's do that again. Set camera, toggle this off. Remember, whatever view you're in is what camera shows up. Yeah, so then I can move my camera, and I can hold shift, and I can pull my camera back. This is the back camera, right? What used to be orthogonal, but I've made it. So I've made that a perspective view, and so I get the building. So the front of it's kind of flat, but then the perspective of it, like the depth of it, vanishes back. So it's almost like a one-point perspective, okay? And I did that, again, by taking an orthographic camera, like the back camera, and changing the projection from parallel to perspective. Parallel would mean that all the lines that are coming at me are parallel, which means that they are lined up in front of each other. If I change it to perspective, they actually vanish on a single point, okay? So from parallel, which just goes to infinity, to perspective, which goes to a point. And then if I do this is where the Hitchcock camera comes in. If I go into set camera and I adjust the lens length and dolly, I can adjust it. So this is actually what it's like as an elevation, and then I can begin to add like more depth to it, and I get kind of like a Paul Rudolph. If I go through and I hide these, then I can begin to read the building. Like, imagine if you cut a section through it, though, and then you begin to play with that depth of it. Again, just like a Paul Rudolph, one of those perspective sections that he does. You guys know what I'm talking about. You can do this in Rhino, all right? So you take an orthographic camera, and you can do this on top view, too. Take the top view and then begin to, like mess with the depth of it. You make a one-point perspective out of that, okay? So, again, let's actually play with it with the top view. So if I have the top view, and I change it from parallel to perspective, and then I might just kind of zoom in. I'm adjusting the location here by doing that, and then I'm going to hide. Ooh, got a bunch of geometry here. Hide the geometry. I can go through and I can adjust the lens length. Kind of matrixy. Now, again, use this for good and not for evil. Like, you don't want to just like willy-nilly distort the thing. What you want to do is you want a drawing that communicates what you want to say, okay? And for some, projects, like just as sometimes a worm's eye view of a building is good, or like seeing the building from the underside is good. Sometimes the way to understand it, maybe you're talking about the circulation, is to do this kind of a view of it, right? It's not a realistic view, but it might be analytical, okay? So where the camera is, the like focal length of it, you know, all those different variables are how you make an analytical camera for your project. Okay, so for your building, for your project, you guys have moments. I'm sure Betsy has you guys thinking about certain moments in your building, like where you like cross a threshold or where you have a particular view. Set that up, like make that camera. You know, even as you're modeling it, build that in and save that camera in your file. Okay, and keep going back to it. You know, there's probably a view as you crest the hill, you know, seeing the entire building. You know, like there's that experience. Or like, what if you're like driving a car to it? What if you're taking a walk through the cemetery and you see your building in the distance? Like all these experiences of it, that's a camera. Cameras are free. You know, they don't take up a lot of space. They don't cost you any money. You can make as many as you want for the different views that you want, and then it's just going to make your life easier when it comes time to like making your renderings. You can just fire them off, you know. Anyway, so that I just wanted to give you guys that. Like, I think that cameras are not something that really gets talked about like too much. I don't particularly like the way that Rhino does cameras, but this is how it does them. Other programs that work for animation have more sophisticated camera controls. Rhino's not meant for that. I think we've talked about that, but it's fairly good. You can get a precision, you know, camera. So anyway, as you're working with it, like experiment with that. Talk to me if you can't get it to do what you want it to do. Like if you have a particular thing in mind, I can look over your shoulder and we can kind of play director. We can find that exact angle you want. Okay, but these are really great, and they're great, you guys, for like, you know, even as you're thinking about your building, like take a shot from your camera, take a screen capture, and then draw on top of it with trace paper to think about different options. Okay, to take a screen capture, it's really easy. You just go to File. You go to View and Capture, and then you can just say to File, right? And then you can just change the type. You can say Target. You can say, you know, my image, and that'll save of that view, you know, right on your desktop or wherever you save it to. Okay. So that, you print that off on the school printer for like 25 cents and then take your trace paper and draw over that, okay? We'll talk about rendering very soon, but if you just want to, for this week, if you're working on your stuff for Studio, this is a quick way to get stuff out of your model so you can draw on it, okay? You can do Make 2D like we used before, although that may be more trouble than it's worth right now. Does anybody have any questions about the technique? Does it all seem to make sense? What do you think? Did you guys cover this before? Okay. Again, like I know Revit, you know, does it differently, and I, you know, like Maya Studio Max. This is just how Rhino does it. But I think with this, you can pretty much make any view you want, you know. But take a look at that. So for the rest of the day, guys, Sam is here and I'm here. We can answer questions about cameras. We can answer questions about what you're doing for your model or for your precedent. If you have questions about how to make something or just how to proceed, that's what we're here for. Okay, we've got until quarter after, so make some good use of your time. I'll post this video when I get home tonight. In the meantime, if you have any questions, you can send me an email. All right.